Greetings everyone, welcome to yet another topic in coordination compounds, that is nomenclature. Nomenclature means naming of coordination compounds. So according to IUPAC nomenclature, there are certain rules that has to be followed by naming coordination compounds. These rules are shown in the screen. First rule is this. In a complex, the cation part is named first for both positively and negatively charged coordination entities. If the cation is an atom or if it is a complex, the cation part is the first part that has to be named, followed by the anionic part. Second rule is ligands are named in the alphabetic order as prefix to the central metal atom. So, for example, this complex. Here, the ligands are this, ammonia molecules. So, before the name of the central metal atom, that is cobalt, this ligand's name should come in name. So while writing the name for this complex, we should write how many amines are there? Hexamine, cobalt, dash, 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 dash. That should be the proper way of writing the name. So ligands are named in the alphabetic order. For example, consider this example, a complex of nickel. Here, two types of ligands are there. A Cl minus is there, and also a triphenyl phosphine ligand is also there. So the naming is done in such a way that the first priority, the first name should be that of the chloride, because alphabetic order Cl is coming first, followed by the P. So the naming should be like dichloro, dichlorido, plus triphenyl phosphine, nickel, etc. So we have first two rules are, if for a complex a cationic part is there and an anionic part is there, always begin with the naming of cationic part followed by the anionic part. And ligands are named in the alphabetic order and they are prefixed before the metal name. Metal and like chlorido, nitrito, etc. etc. And third rule is that if the ligand is anionic in nature, the ligand's name should end with O. For example, Cl minus. It's an anionic ligand. It's negatively charged ligand. So its name is like this. Chlorido. NO2 minus. This is an anionic ligand. Its name is, proper name is nitrito. So always the anionic ligand's names ends with O. For neutral and cationic ligands, they are named as such. There are certain exceptional cases that are for water molecule, the name is aqua. For ammonia molecule, we are not using ammonia as the ligand name, we are using amine. For CO, we are not using carbon monoxide or something like that. We are using the name carbonate. And for NO, we are using nitrosyl name in the naming according to the IUPAC. Okay. So if more than one of the same ligand is present, like here, two chlorides are there in this complex. So we will prefix mono, di, tri, etc. before that name of the ligand. For example, here dichlorido. That means 2 Cl are there. And if the ligand name has a numeric part, for example, here EN, ethylene diamine or ethene 1,2 diamine. Here a di part is there in the molecule's name. Ethane 1,2 diamine. in such cases, what we do is that if it is En twice, we are not using di, di is di is not used. We at that time we are using this terms like bis, tris, tetrakis, etc. So to understand it, we are taking this example. Here the naming is done in such a way that before metal's name we are adding the ligand's name, right? Dichlorido, that too in the alphabetic order. C is coming before P. Therefore, we are beginning with dichlorido bis triphenyl phosphate because there is a tri term here. So we are not using tri because it will make the naming a bit difficult to follow. So we will use bis triphenyl phosphate. Triphenyl phosphate is there. Bis 2. This 2 is represented by this name. Bis triphenyl phosphate nickel 2. So what is this nickel 2? That is the next row. That is oxidation number of the metal in the complex is written in numerals after the metal name inside a parenthesis. For example, here this is a neutral complex. So Cl has -1 charge. Triphenyl phosphine has a neutral complex. So to maintain the electrical neutrality, the oxidation number of nickel will be +2. And this oxidation number is shown after the name of the metal as Roman numeral. The next rule is if the coordination entity is a cation or neutral, the metal is named as the element. For example, here CO, NH3, 6 times CO3. All charges CO3. So here the complex part is the cation. So while writing the name of the complex, we will write hexamine, cobalt 3. Charges, oxidation number is 3, cobalt 3. For neutral complexes also, this is done in a similar way. For example, this complex, which is a neutral complex, nickel, so tetracarbonyl. Tetracarbonyl. So the naming will be like tetracarbonyl, nickel, like that. So that is the case for a cation and neutral complex part. And if the cation coordination entity is an anion, the name of the metal ends with 8. For example, here the complex part has a -2 charge. That means this is the all coordination entity is an anion. Therefore, the naming should end with like cobalt 8. The name of the metal should end with 8. And another important rule is some of the metals use their Latin names. For example, iron use ferrate, or silver we use when silver is a part of the anion, we'll use argentine. So we will see some examples. First, consider this complex CrNH3 3 times, H2O 3 times, Cl. So which all are the complex ligands there? This ammonia is the ligand, water is the ligand. So we have seen that ammonia is named as amine, water is named as aqua, and the metal, central metal ion is chromium. And now the complex coordination entity is a cation, right? So Cl minus ions are the counter ions, and the complex part is a cation. So cationic part is named first. How will you write the name? We should first write the names of ligands. Which all are the ligands? Amine and aqua. So in alphabetical order, amine will be coming first, followed by aqua. So how will you write the name? Triamine, triaqua, chromium. Now we have to find out the oxidation number of chromium. How will we find out? This is a neutral molecule. This is a neutral molecule. And the charge on this complex part is +3 because that is being utilized by the 3Cl minus molecule. So chromium has a +3 oxidation state. So after chromium we should open the parenthesis and write Roman numeral 3. And after finishing this, we will write chloride for this counteracts. Coming to a second example, here the central metal ion is cobalt, which all are the ligands. There's 3 molecules of this ligand, that is ethane 1,2-diamine. And the counter ions are sulfate. So I will write this is ethane 1,2-diamine. A di part is there in the name of the ligand. So we will not use di-tri-tetra, we will use bis tris tetrakis. We will write tris ethane 1,2-diamine, cobalt, a number sulfate. So we will find out the oxidation number. Sulfate is there. What is the charge on sulfate group? Sulfate group has a charge of -2. How many sulfate groups are there? 3 sulfate groups are there. So total charge will become -6. So the complex part also has a charge of +6. Two complex parts are there. Therefore, for each complex part, the charge is +3. Since this molecule is a neutral one, the +3 is contributed by the cobalt. Therefore, the oxidation number of cobalt is 3. That is written after writing cobalt. Open the parenthesis and write Roman numerals 3. This is the cation and this is the anion. Both the anion, we will first write the cationic part's name, which is the central metal atom, silver. Here also, for the anionic part also, silver is the central metal atom. And for cationic part, the ligand is ammonia. So we'll write amine. 2 ammonia are there. So we will write like diamine, silver. So we will write about the oxidation number later and followed by the anion, that is dicyanoargentate. So here now we will find out the oxidation number. Ammonia is a neutral molecule. Cn has -1 charge. So the oxidation number of silver is, here is total, the complex has a charge of 0, will be neutral. So the oxidation number of silver in cationic as well as anionic part is +1. So diamine silver 1, dicyanoargentate 1. That is the name of the